You've been wrong about animals this whole time, the truth will blow your mind. Unveiling the hidden world. We often believe we understand the animals that share our world. From the playful antics of dolphins to the industrious nature of ants, we assume their behaviors are well documented and predictable. However, beneath the surface lies a realm of secrets and complexities that challenge our perceptions. This series aims to delve into the enigmatic aspects of animal lives, revealing behaviors and intelligence that often go unnoticed. By exploring these hidden facets, we not only gain insight into the animal kingdom but also reflect on our own place within it. In this journey, we'll uncover stories that defy conventional understanding. For instance, recent studies have shown that certain fish species can recognize themselves in mirrors, a trait once thought exclusive to humans and some primates. Such discoveries compel us to reevaluate the boundaries of animal cognition and consciousness. As we navigate through these narratives, we'll encounter behaviors that are not only fascinating but also indicative of complex emotional and social structures. The animal kingdom is replete with examples of ingenuity and adaptability. From octopuses using tools to birds exhibiting problem-solving skills, these instances highlight the sophisticated mechanisms animals employ to survive and thrive. By shedding light on these behaviors, we aim to foster a deeper appreciation and understanding of the diverse life forms that inhabit our planet. Moreover, understanding these secret lives has profound implications for conservation efforts. Recognizing the depth of animal intelligence and emotion can influence policies and practices that affect their habitats and well-being. It's a call to action, urging us to consider the ethical dimensions of our interactions with the natural world. As we embark on this exploration, prepare to be surprised, challenged, and inspired. The stories that follow are not just about animals, they're about the intricate tapestry of life and the unseen threads that connect us all. The social lives of animals, social structures in the animal kingdom are as diverse as they are intricate. Elephants, for example, exhibit profound familial bonds, mourning their dead and displaying behaviors indicative of grief. These matriarchal societies rely on the wisdom of elder females to guide and protect the herd, showcasing a level of social organization that parallels human communities. Similarly, wolves operate within tight-knit packs, where each member has a defined role. The alpha pair leads, but the success of the pack depends on cooperation and mutual support. Hunting strategies are coordinated, and the care of pups is a collective responsibility, emphasizing the importance of social cohesion for survival. In the avian world, species like the African gray parrot demonstrate remarkable social intelligence. These birds not only mimic human speech but also understand context, using words appropriately and even engaging in basic conversations. Their social interactions extend to problem-solving and teaching behaviors, indicating a complex cognitive framework. Marine mammals, such as dolphins, form pods with intricate social hierarchies. They communicate using a series of clicks and whistles, each individual possessing a unique signature sound. These vocalizations facilitate coordination during hunting and reinforce social bonds, highlighting the sophisticated nature of their interactions. Understanding these social dynamics challenges the notion of human exceptionalism. It reveals that the capacity for complex relationships, empathy, and cooperation is not exclusive to our species. By studying these behaviors, we gain insight into the evolutionary roots of our own social structures and the shared traits that bind us to the animal kingdom. Communication beyond words. Communication in the animal world transcends vocalizations. Bees, for instance, perform intricate dances to convey the location of food sources to their hive mates. This waggle dance encodes information about distance and direction, demonstrating a sophisticated method of nonverbal communication. Cephalopods like cuttlefish and octopuses utilize color changes in body patterns to communicate. These rapid transformations can signal aggression, mating readiness, or camouflage, serving as a dynamic language of visual cues. Such abilities underscore their advanced neural capabilities and adaptability. Elephants communicate through low-frequency rumbles that travel long distances, allowing them to coordinate movements and maintain social bonds even when separated. These infrasonic calls are often accompanied by tactile signals, such as trunk touches, reinforcing their messages and emotional connections. Birdsong is another avenue of complex communication. Songbirds learn and modify their tunes, using them to establish territory, attract mates, and convey alarm. The learning process involves listening, practice, and refinement, akin to language acquisition in humans. These diverse communication methods reveal the depth of animal intelligence and the myriad ways species interact with their environment and each other. They challenge us to broaden our understanding of language and expression, recognizing that meaningful communication is not solely the domain of humans. Tool use and problem-solving. Tool use, once considered a hallmark of human evolution, is prevalent across various animal species. Chimpanzees fashion sticks to extract termites from mounds, showcasing foresight and manual dexterity. This behavior is often taught from one generation to the next, indicating cultural transmission. Crows and ravens demonstrate remarkable problem-solving abilities. They can manipulate objects, understand water displacement, and even plan for future events. Experiments have shown that these birds can use tools in sequence, a cognitive feat requiring advanced reasoning. Sea otters use rocks to crack open shellfish, a behavior observed to be passed down through generations. They often have a preferred tool they carry with them, indicating individual preferences and learned behaviors. Dolphins have been seen using marine sponges to protect their snouts while foraging on the seafloor. This tool use is primarily observed in certain populations, suggesting a form of cultural behavior unique to specific groups. These examples underscore the cognitive complexities present in the animal kingdom. They highlight the capacity for learning, innovation, and cultural transmission, challenging the notion that such traits are uniquely human. Emotional depth and empathy. Emotions in animals are often dismissed or underestimated. However, numerous studies and observations suggest that many species experience a range of emotions, from joy to grief. Elephants, for example, have been observed mourning their dead, displaying behaviors that indicate a deep sense of loss. Dogs exhibit behaviors consistent with empathy, often responding to human emotions with comfort or concern. Their ability to read human cues and react appropriately suggests a level of emotional intelligence that facilitates the human-animal bond. Primates like bonobos and chimpanzees engage in reconciliation behaviors after conflicts, indicating an understanding of social harmony and the importance of maintaining relationships. These actions reflect emotional awareness and the capacity for empathy. Rats have demonstrated empathy-driven behaviors in laboratory settings, choosing to free trapped companions even when a food reward is available. Such findings challenge our perceptions of rodents and their emotional capacities. Recognizing emotional depth in animals prompts a reevaluation of how we treat and interact with them. It raises ethical considerations regarding animal welfare and the responsibilities we hold as stewards of other sentient beings. Intelligence in the invertebrate world. Invertebrates, often underestimated, possess surprising cognitive abilities that challenge our assumptions. Octopuses, in particular, have demonstrated advanced problem-solving skills, such as opening jars, escaping enclosures, and mimicking other animals. Despite having short lifespans, their ability to learn from experience and adapt to new environments is remarkable. They also display curiosity and play behavior, further suggesting an internal complexity we're only beginning to understand. Bees, though tiny, show impressive feats of learning and memory. They can recognize human faces, navigate long distances using the sun and landmarks, and even grasp abstract concepts like zero. In experiments, bees have learned to solve puzzles to access nectar, proving that intelligence doesn't always require a large brain, it requires efficiency and adaptability within an environment. Ants operate through collective intelligence. While an individual ant might not seem impressive, their colonies function as highly organized units. Ants engage in farming, build elaborate underground cities, and use pheromones for traffic control and alarm signaling. Their teamwork is so effective that it often outperforms human-designed systems in efficiency and resilience. Spiders also show signs of intelligence, especially those that construct complex webs or use hunting strategies. Some species adapt their web architecture based on weather conditions and prey availability. Jumping spiders, with exceptional vision, can plan routes to ambush prey, indicating spatial reasoning and patience, traits commonly associated with more complex animals. These examples reveal that intelligence in nature manifests in diverse and surprising forms. Rather than measuring intellect solely by human standards, we must recognize that many animals, even those without backbones, have evolved their own ways of thinking, solving problems, and interacting with the world around them. Cultural transmission and learning culture, often considered a human trait, is present in many animal societies through the passing down of learned behaviors. Chimpanzees teach their young how to use tools, such as rocks for cracking nuts or sticks for fishing termites. These practices vary by region, showing that different chimp groups have distinct traditions passed across generations. Orcas demonstrate unique cultural behaviors based on their pods. Some pods specialize in hunting seals by sliding onto ice floes, while others corral schools of fish. These techniques are not instinctual, they're learned and shared within families. Young orcas observe and mimic the adults, much like human children learning from parents. Birdsong provides another clear example. Young birds learn to sing by listening to adults. If raised in isolation, they produce distorted songs. Moreover, regional dialects develop among bird populations, creating distinct accents passed from generation to generation. These vocal patterns can even influence mate choice, making them crucial to the species' culture. Even among insects, cultural learning appears possible. Bumblebees have been trained to pull strings or roll balls to access nectar, and once one bee learns, others watching can quickly adopt the same method. This observational learning suggests basic forms of social transmission previously believed exclusive to vertebrates. Understanding that animals have culture forces us to reconsider how we view the animal kingdom. It proves that learning isn't purely instinctual, it's also social. By acknowledging that animals possess tradition, teaching, and imitation, we get a fuller picture of their intelligence and social lives. Hidden night lives, nocturnal strategies. When the sun sets, a different world awakens, one filled with specialized creatures adapted to darkness. These nocturnal animals have evolved extraordinary senses and behaviors to navigate and survive the challenges of night. From sensitive hearing to night vision, these adaptations show nature's creativity in overcoming the limitations of light. Bats are prime examples of night experts. Using echolocation, they emit high-frequency sounds and interpret the echoes to see their environment. This skill allows them to hunt midair insects with precision and avoid obstacles in total darkness. Some bats even adapt their echolocation patterns based on their surroundings, showing flexible intelligence. Owls possess exceptional low-light vision and nearly silent flight. Their ears are positioned asymmetrically, enabling them to pinpoint sounds with accuracy. These adaptations make them deadly hunters of rodents and small prey. Their ability to locate movement under thick snow or dense brush is evidence of extreme sensory fine-tuning. Nocturnal mammals like lemurs, pangolins, and fennec foxes use their heightened senses of smell and touch to forage at night. Some, like the eye, tap on trees to locate insect larvae, a technique similar to echolocation. These behaviors show how animals create mental maps of their environment using non-visual cues. Night also offers strategic advantages, avoiding predators, reducing competition, and escaping heat in desert regions. Animals active at night are not simply avoiding danger, they've mastered an entirely different world. Studying them reveals how behavioral rhythms align with environmental pressures, adding another layer of complexity to animal life. Deceptive behaviors and animal trickery. Nature isn't always honest. Deception is a powerful survival tool used by many animals to trick predators, prey, or even their own species. These strategies, mimicry, camouflage, and behavioral manipulation, require a level of awareness that suggests cunning, flexibility, and intent. The mimic octopus is a master of disguise. It can change its color and shape to imitate venomous sea creatures like lionfish and sea snakes, fooling predators into thinking it's dangerous. This quick-thinking deception shows an ability to read the environment and choose the most effective disguise. Some birds, like the African drongo, engage in vocal mimicry to steal food. They imitate the alarm calls of other animals, causing them to flee and drop their catch. The drongo then swoops in to claim the prize. This behavior requires timing, memory, and an understanding of cause and effect. Cuttlefish, especially males, are known to use sneaky mating tactics. When a rival male is nearby, a smaller male may change its appearance to resemble a female, avoiding conflict while secretly mating. These actions show situational awareness and adaptive decision-making. Insects also use trickery. Certain spiders mimic ants in both appearance and movement to infiltrate ant colonies undetected. Some butterflies evolve wing patterns that resemble the eyes of larger predators, scaring off would-be attackers. These evolutionary tricks are a testament to how deception drives adaptation. Such behaviors blur the line between instinct and calculation. They challenge the assumption that animals are purely reactive, proving that manipulation, distraction, and even psychological misdirection are tools used across the animal kingdom. What this means for us: after uncovering the hidden complexities of animal lives, we're left with a deeper truth. Animals are not simple, instinct-driven beings. They think, feel, adapt, learn, and even deceive. From toolmaking to cultural transmission, from empathy to trickery, their behaviors echo ours in more ways than we imagined. This realization changes our ethical responsibility toward animals. Recognizing their emotional and cognitive capacities means we must reconsider how we treat them, in homes, in the wild, and in captivity. It's no longer enough to see animals as resources or entertainment. They are sentient beings deserving of respect and care. In conservation, understanding the intelligence and social needs of animals helps shape more effective protection strategies. It informs how we preserve habitats, reduce human-wildlife conflict, and design wildlife corridors that honor animal behavior. The better we understand them, the better we can coexist. For individuals, this knowledge can foster empathy. Whether it's looking differently at a crow scavenging in a parking lot or appreciating the silent communication between a herd of elephants, these stories connect us. They remind us that life, in all its forms, is deeply interconnected. Ultimately, the secret lives of animals challenge our perspective on intelligence, emotion, and the essence of life itself. By uncovering their stories, we don't just learn about them, we learn about ourselves. And maybe, just maybe, we become better stewards of the world we all share.